So here's the device for lesson 118's assignment, creating a device that saves the position of the servo when power is off. So it returns there next time it boots up. Just to show you, I have it connected to the computer to show you that currently the My Data folder is empty. I've deleted the file that I created while I was building the project just so you can see how it operates the first time through when there's no data available. So now I'll unplug the USB cable. Now you can see the USB cable's unplugged. It's completely independent of anything. I'll turn the power on the breadboard on, and you'll see the server goes through from 0 to 180 and back to 0 just to kind of reset itself, and also to give me a indication for future starts when there is a file there that it actually is moving and not just staying where it was left. So now I'll push the button to move it increments. It goes in 5-degree increments. So increment it up, the other button will increment it down. Now you can see that's at a maybe 45-degree angle or so. I'll turn the power off and then turn the power on. You'll see it'll go through that sequence of going to 180 and back to 0, and then it should return to that location. And then again, I'll move it so that sorry, our dogs are playing in the background, but and now I'll turn the power off again, turn it on, and it goes back. So this is the code for lesson 118's assignment, creating a servo that with 2 buttons that increments the servo position, and that when on power off or when you turn it off, it saves the servo position so it returns there the next time it's booted up. So import the libraries. I'm using the servo state machine library I created in earlier lessons. So import RP2, import pin, time, and the UJSON. I set up my server object or my state machine servo object here. Just give it a little bit of time to activate. And then I set up the logic for the button interrupts. I chose to use 2 separate state machine buttons, IRQs, rather than doing the thing where we monitored 2 buttons at once. Just seemed like I had the state machines available, and this would be a cleaner path or a smoother path. So set up the logic for waiting for a button push and activating an IRQ. Set up the pins for each button and the state machines. The up state machines using state machine 1 because this one's using state machine 0. The servo is. Set up the other pin using state machine 2. Make those 2 state machines active. This is where I do the move of the servo. I called it lock state machine just because you had mentioned that it was like a door lock, so I just went with that theory. Moves the servo to 180, takes a break, moves it back to 0, and then I use this try and accept logic to bypass any issues on startup. If there wasn't a my data or a servo data file available, I didn't want the whole thing to freeze. So if there is a my data or a servo data file in the my data folder, it will load that and then move the servo to that angle. And then after that, we go into the 2 handlers, the up button handler and the down button handler. They're exactly the same, except one adds 5 to the servo and one subtracts 5 from the servo. And a little bit of the logic here, if it's over 180, I make it equal to 180 so you don't drive the servo in here. If it's less than 0, I make it equal to 0. But otherwise, these are the same. So again, I set a servo angle to 0. This is again for if there was no servo angle at the first time through, we wouldn't get a thing. These print statements are actually, I had a little bit of a pin issue that I needed to debug, so I could actually remove those, but they're still left in from my debugging process. But then and then again, I try an except loop so that if the first time through when there's no servo data, it wouldn't crash. But basically load the servo angle, add 5 to the servo angle, or subtract 5 for the down button, and then move the servo to that angle, and then save it to the servo data file. And the down button is exactly the same. And then here are just the two monitoring for the IRQs and directing them to the two functions to handle the button presses. So pretty simple, pretty straightforward, almost entirely on the state machine, except for I guess these two functions obviously aren't. But obviously I had some challenges. I had to do some debugging, but it was a fun project and I enjoyed doing it and learned a lot.